Hello, this is Liam Quinn, dialing in from Canada, country just north of Mexico. Alright, to talk about the matcha, which is a small part of the overall system that the customer wanted, but it's the bit I wrote. I wrote a lot of it, I didn't write it all. The purpose of the matcha is to mark corresponding nodes in the two input documents, the original and the changed document. And the method we came up with was a pipeline of matcha functions. You can write your own matcha functions, so it's open. You can run the provided ones and yours in any order and any combination, even multiple times. So it's very configurable. The default configuration is intended to work for a wide range of documents, though. The goals for the matcha and the framework were that it should be easy to add new matcha functions, not just possible but easy. The code should be easy to understand and maintainable. There should be no really slow algorithms, so it can be slow but not glacial, no NP complete, and ideally no n squared for large N. No out of memory errors for reasonable documents, and people writing matchas, both us and other people in the future, should be isolated from representations, so functional. So I wrote a functional API, an API of functions, that is, to access things. And every node in both documents, the original and the changed, should be marked in some way by the matcher. It can be marked as identical, it can be marked as corresponding, it's a match. It can be, but maybe it's got different attributes or something. It can be marked as an insertion or a deletion or a change, the text content is different, or a move, or maybe the element name is different. Later we made special case wrap and unwrap and split join too, I'm not sure. Again, performance is secondary to correctness, but still important, but secondary to correctness. It should only mark things that are different in the two documents, so I think we've achieved that. I said it should be easy to add a new matcher, and experience says it is easy. Sometimes it's easier to add a new one than to fix an old one, and that's not ideal. So, but that's life with programming, right? So inside the matcher framework module, we have a variable called matcher definitions, and it's a map of maps. So the keys are the name of the map, and the values are maps that contain a matcher and an about. The matcher is a function. In this case, most of the matchers are in the M module, and find pairs with 3 arguments is all of the matchers are like that. I'll explain that in a minute. And about finds paragraphs with identical content. That's there so that you can get a list of all the matchers and a short description of each of them. And matcher functions are, as I said, 3 arguments. The first is a matchbox, as we call it. It's a XPath4 record type, or XQuery4 record type. It's a map of the knowledge we've gained so far, the program's gained so far. And there are 2 document nodes. The matcher must return a new matchbox map, and the extra type checking is really useful. So basically, it receives this map as an input. It will call functions that update the map, or actually return new copies of the map with extra information in them, or less, or changed information, and that's what it will return at the end. A matcher typically walks the tree and maybe walks both trees in some way, or some subset of both trees. So I added a visitor pattern module from the good old patterns book from years ago for walking document trees and calling a function on each node, and you supply it a map with functions like element this and document node that, and so on. You can give whatever you want. You don't have to give them all. Most often I give only element and document node. Works well, and it also has a test for whether to descend into a node. So if you supply that and it returns true, then it ignores the node and any children. So that enables matchers easily to skip nodes, pairs of nodes marked as identical because they're deep equal by an earlier matcher. The visitor pattern is partly because I tend to do more XSLT than XQuery, and I misapply templates, I think. But you can't use. You can use neither for each nor fold left for this because you can't see the preceding information as you go forward. So talk about a couple of actual matchers. Find pairs walks the document and builds a map of space normalized text values and looks to see if there's elements with the same normalized text in both documents once it's built the map. And if a key that it's built has only one node from each document, then it calls them tentatively matched. That is, it matches them with a low confidence value. So when you add a match, you give a confidence. Another one is match by ID, which looks at IDs of nodes using @ID and XML ID by default. And if a node in document 1 has the same ID as a node in document 2, then it checks to see if they're deep equal, and if they are, it marks them as identical, and then things using the visitor pattern, for example, can easily avoid going back into them. We don't want them to. We've identified that they correspond and they're the same as each other. They're identical. Otherwise, it marks them as matching if they both have the same ID. So that's useful. There's a more complicated one that looks at sections and tries to find a matching container element based on matched paragraphs inside it. And if paragraphs match multiple containers, it tries to choose the most likely match. It uses text similarity. I ported an algorithm from a technical paper. It's cited in our paper, and it's also used in Apache Lucene for text similarity. Stemming, in our case, stemming primarily German, but it turns out it works pretty well for English as well. So the section matcher, if we're considering the section at the top, or no, we're not. We're considering the section on the left. Let's do that one. So we're considering the section on the left, and we've got kind of a couple of out in the woods matches to other sections, but most of them match this section, including the title, which is weighted more heavily than other elements, again using XML semantics. And so we say these two sections correspond, and this paragraph 2 should probably come in here. This paragraph 3 should, this paragraph 4 down here should probably be the one from the top section. So that's a fairly complex matcher. The matchers make use of a configurable list of elements. It's kind of only, right now it's actually in a variable, but that's easy to edit. But we're working on a configuration file. We have a concept of substitution groups. This is not quite the XML schema one, but equivalent elements that could, if an element name has changed, we'll only accept them as corresponding if they're plausible. So if you change an emphasis into a chapter, for example, we've gone wrong somewhere and we don't add that as a match. And titles are treated specially, so titles, captions and so on, as are tables. And we saw earlier the table matcher actually does an okay job. It's quite good. Functions on matches generally add the match or remove it, and most often add it and return a new matchbox map. So it's not unusual for a run of this software to call map::put 1,000,000 times, for example. And we're pleased that that's fast in BaseX. Thank you, BaseX people, you're awesome. The client was already using BaseX for the larger program, of which this is part, by the way. So function, you can ask some of the specific. We have his paragraph like, his section like, and his title like functions for changing the input vocabulary a bit. And all the logic around adding a new match is in this guy, make match object. It really did simplify development and debugging to use a functional API like this. Make match object actually returns a new match box with the match added if it wants to, if it's plausible. And right now all elements are matched. A very clever inline matcher that Nico wrote works within paragraphs. Sometimes changes appear as insertion and deletion when you'd rather have them be a change or remove or something. It's not perfect. It's easy to add new matches. Debugging them can be hard, but again the record types really helped. Matchers can use domain-specific knowledge, and often do, and we're currently working on improving the configuration. So, it's an open XML differ in that users can add matches of their own. It gets reasonable results. Performance is acceptable. Takes anywhere from, well, on an old computer, a few seconds to a minute. And we're continuing to improve it, of course. So, thanks very much.